All right, guys, you are here today because you have been nominated as the worst brazers in the company. No, I'm just kidding. Pat yourself on the back. No, so we did this class probably about a couple months ago with 4 people just to kind of test it out and get the feel for what it feels like and kind of get the rhythm of what the class should be like. I took a factory class 10 years ago. So I used to work for a manufacturer called Daikin Comfort Technologies. I worked there for 2 years. 9 years ago, they rolled out a class called the Brazing Dojo. That Brazing Dojo was a 5-day class on a factory floor of just nothing but brazing. And it's not just the science behind it, but the art behind it, the types of metal that you use, brazing copper to aluminum, aluminum to aluminum, copper to steel, aluminum to steel, brass to brass. I mean, we covered literally everything for 10 hours every day for 5 days. And so this is a small version of that class that I took 10 years ago from the factory side. We had someone from Japan come in, and over there, their culture is that, you know, their father's father did nothing but brazing his entire life. His son did nothing but brazing for his entire life, and then you did nothing but brazing your entire life. And so they have mastered the art of brazing, which is why we, when I took that class, I thought I knew how to braze from doing it 10 years in the field, and then I realized I knew nothing about brazing. So this class is designed to not make you guys advanced brazers or in a format make you experts in brazing. This is to introduce you to the basic theory, what brazing is, how to use the tools, how to assemble the gauges, what means what, and allow you to ask questions along the way to get you comfortable with the process of brazing. We're going to put all of our torches together. We're going to cover the safety stuff first, and then we're just going to jump right into brazing. We're going to be brazing all day today. So you're going to braze somewhere close to 5 sets of what I like to call the bridge. So the bridge is 2 elbows, one on the left, one on the right, and a coupling in the center. You're going to do this in 3/4, 3/8, and then at the end of the today, you're going to do inch and an eighth, which is the hardest to braze out of all of them. In residential air conditioning, inch and an eighth is probably the biggest you're going to get into. You get into rack refrigeration, you're going to get into 2-inch, 3-inch, 4-inch, 5-inch, 6-inch, and 8-inch. And that just is a specialized class all by itself just to get that done in its own. So you'll find a lot of inch and eight in the field and you'll realize it's not easy to braze. And so in this setting, this is a controlled environment. You guys are going to have all the angles at your disclosure here. You can get to all the areas to get to. It's going to be nice and comfortable. You're going to be standing up. You're not going to be upside down in a hole, on a roof, under a table. It's not going to be raining. So this is a controlled environment to get you comfortable with the skills that you're going to need to go out in the field and then practice over and over and over again. On your table, you should have 2 sets of PPE that you need for brazing. You should have gloves, and you should have goggles or glasses, safety glasses. When we're brazing, let's touch on the gloves really quick. Obviously, this is a very easy one to cover. What happens when we braze pipe? It gets hot. Okay, I don't have to explain to you what a 2nd degree or a 3rd degree burn looks like and how it takes a very long time to heal. But you should always be wearing gloves when you are brazing. You can take your gloves off to set your torches up. You need the dexterity to get these small fittings connected and adjusted. Get your torches set up to where they're ready to go, and then you can put your gloves on last. But you should always wear gloves while brazing. And we can go even a step further, and we can give you, they make Kevlar gloves, the sleeves. They actually will go over your wrist and up your arm. That's for small enclosure brazing. So if I'm brazing in a small cabinet under my table here or something like that, and there's a possibility that I have to move a certain way to get the flame a certain way, and it might either graze my arm or it might accidentally touch a pipe that I'm brazing. Let's say I'm brazing 6 pipes in a chase. I would probably put my gloves on just because the likelihood of me moving a certain way to get it done, I might forget where I'm focusing on this, but I'm not focusing on this, and the last thing you want to do is land your arm on that pipe. And it's going to happen. You're going to braze, you're going to get a piece of silver solder, right? And you're going to get it really hot, and then you're going to set it down, and then you're going to rest your arm down on top of it, and you're going to have this nice, beautiful line down your arm from the silver solder. Now, it's not going to be as hot as if you touch the tip of this torch, but still, these are things that we have to consider when we talk about safe practices in brazing. Assume everything is hot until it's not, right? Usually we have wet rags in our buckets here for today, so we're just going to go overboard, and a lot of you guys are going to touch hot pipes, and you're going to learn really quickly that we shouldn't do that. So And then the second piece of PPE that we talk about with brazing, these are a little overkill. So our safety team was nice enough to actually get us class 3 glasses. So if you take your safety glasses and you look at them, you'll notice that you can actually see through them. The issue we have with our last class is the PPE we got, they were actually class 5. And so the difference here is class 3 is actually what you should be using for brazing, right? Class 5 is what you would use for welding, or for a larger frame of brazing, such as like a rosebud tip that's designed to cut metal, right? If I'm cutting steel with a set of torches, I would use a class 5 and not a class 3 like you have there. Normal brazing doesn't have a very large flame. It doesn't have a very bright blue, white flame like you would with welding, and so we can use a lower class of glasses. That was the biggest complaint, is that people walked around and they had these glasses on and they're like, man, I'm learning how to braze for the first time, but I can't actually see the pipe. It just makes it more difficult. You'll notice these also flip up, so you can actually look at your pipe while you're brazing, or not while you're brazing. You can look at your pipe before you braze, right? And then you can flip your glasses down, braze, and then flip them back up to actually see what's going on without actually having to pull the glasses off. There's nothing worse than having not enough hands to hold your torches, to hold your silver solder, and then have to do this and look at it and then put it back up and look at it, or take your glasses off. So just another level of forethought there from our safety team. So between the glasses that you have there, which we will wear while brazing, and again, so let's talk about really quickly, just because I know that my safety guy won't let me live it down. Why do we have safety glasses? Why are they colored?
Oh, the blue light. The blue light.
Okay, what about the blue light? Why does it have to be green? Why do we not want blue light?
Does it damage the human eye?
Yes, it damages the human eye. How does it damage the human eye?
I think the UV burns it.
So when you weld without glasses, because of the level of UV spectrum light that's emitted in the process of welding, in the process of brazing, it actually can burn the surface of your retinas. It's no different than staring at the sun outside for an extended period of time, right? It's going to burn the surface of your eyes to where the next day, you won't feel it now, but the next day or 2 days later, you'll realize that you can't open your eyes, or your eyes feel red, swollen. It's no different than when you look at a UV bulb inside of an AC system. While it's on, it doesn't burn out right there on the second, but as your time goes on, the scarring starts to take over, your eyes start to get red, they start to hurt, they start to itch. It's difficult to focus on things. And so brazing isn't that intense. You're gonna hear me talk now, and then you're gonna go out in the field and you're gonna braze, and you're gonna not have glasses one time, and you're gonna say, well, I feel fine. It's great. I've done 10 years of brazing with and without glasses, and I'm already noticing a difference now at the age of 33 that there's just certain things where I see spots at times, right? You have to remember that this is a long-term exposure over time that's going to damage your eyes to the point where when you get 40, you need reading glasses, right? So this is just one of those things where although you may not feel it now, right, the consequences of this pipe being hot is instant, right? This gives me pain. The consequences of not wearing these glasses is not instant. This is over time exposure, right, with anything else. So that's why these are important. Am I saying you could get away with doing without it once in a while? Sure, right? You may not have long-lasting consequences of that. However, if you're brazing at a constant, or you're going to be brazing throughout the rest of your career, because you will be, right? You're going to be brazing for a long time. Just better safe than sorry, right? Protect yourself. Just don't run the risk. I don't know about you, but I want to see until, I get really, really, really old. Okay, that's the safety side of things. So let's jump into the actual fun side of things. In front of you, you guys will see that you have disassembled torches, right? So something that I love to cover in this class, and just because we've jumped right into the brazing before, because I go, it's a brazing class, it's just braze. But then not realizing that everybody has different levels of understanding about the equipment, about the torches, about the torch sets, about what each piece does, how it goes together. So today we're going to build these from scratch, and then you're going to learn how to use them. And then this way, you guys are equipped that when you get your own set of torches in your careers, you understand exactly how to put it together, and you don't need help from somebody else, right? This is all about giving you skills and teaching you things that you can take with you throughout your entire lives. Let's talk about brazing in general. So we're going to go through this presentation pretty quickly. I'm a huge learner on just hands-on only, but I like to kind of mix it up with both so you guys have some visual stuff as we go along. So if you have questions, you can kind of just see what we're talking about. All right, so when we talk about brazing, right, we're talking about temperatures that are around probably 1,000 degrees. We're talking about taking a piece of metal and joining it to another piece of metal within the system. We're talking about bonding those two pieces of metal with what we call a filler metal. Those filler metals come in all different sizes and shapes and colors and numbers. For our instance today, we are joining copper to copper, right? And to do that, we use what a lot of people call silver solder, right? Manufacturer calls it B-cup, but this is just a rod of a specific type of metal that's designed to connect two pieces of metals together. You're going to find as you learn brazing and you learn how to do other types of brazing, because brazing is not just copper to copper. Brazing is copper to brass, aluminum to copper, copper to steel. Oh, I got you a short one, my bad. You're going to notice something special. So on this package, it says Silfloss 15. Does anybody know what the 15 stands for? Yes, percentage of silver. So you guys are already ahead of it. You'll also notice on your stick, it is also printed on your stick, right? So if you don't know where your silver solder came from, or you have a mixed batch, or if your tank case is like my tank case and it's got about 1 million of these small pieces in the bottom, and you have to reuse them, on those sticks will tell you what it is and what the brand name is or who makes it and what the percentage of silver is. Now, the percentage of silver in this is just basically telling you that there's 15% silver in this rod, and it's designed to basically, again, connect copper to copper. There's different levels of silver. There's 0%, there's 5%. You may even find 10% from some, off-brand manufacturers. But 15% is the type that we use here. And that's just because, one, it flows very easily, right? It doesn't require you to have an extremely, insanely clean environment to put it on, but also its bond is extremely strong, right? 15% is tried and true. It's just a basic standard. The less silver it has, the cheaper the rods are. So if I wanted to save money, I could do 0%, right? And save some money on the project. However, if I have inexperienced brazers that are using 0%, you're going to find that if water gets in the joint, if oil gets in the joint, if they have oily hands, let's say they go to lunch, they eat chicken wings, right? And they go back and they start brazing and putting copper together. They go to braze it with 0%, they're going to have a hard time getting that silver solder to flow the way that it should around that joint. And so 15% is just kind of a tried, true, tested method and alloy. So, all right, so properties of base metals. There's always the fun stuff of science that we're going to cover here, and you're going to learn this the hard way. Melting point. Does anybody want to take a guess as to what the melting point of copper is? 300 degrees. No, higher than that. 1300. It's 1950. So 1,950. How many people here have seen copper melt? Okay. Now you know it was probably close to 2,000 degrees when it melted. Right? So when we talk about these alloys, these base metals that we're taking to braze, they melt at a much lower temperature than the melting point of the copper itself, right? So this one says on here that the flow temperature is 1,300 degrees, right? It becomes extremely liquid at 1475. So with this type of silver solder, I know that at 1475, it will become a liquid, full liquid, right? When I get it that hot, it becomes a liquid. However, if I get copper this hot, it also becomes a liquid. So we have to get into that sweet spot between the two. So it's somewhere close to about 1,600 degrees from copper. You're going to notice here that every base metal is different, right? Copper is 1,900 degrees, aluminum is 1,200. So if I was to connect copper to aluminum, I'd have to make sure that I preheat the copper before I do the aluminum, because I can get the aluminum way too hot, right? And obviously, something that melts at 1,400 degrees, liquid, would not work when I'm trying to connect something that melts at 1,200 degrees. That will not work. This is a science, right? It's not just, let's just take some torches and try to melt metal together. You have to understand the basic principles of the metal, when it melts, at what temperature to get it to. Now, you're not going to sit here with a thermometer and a torch and wait till it gets to the right temperature. Today, you're going to learn what that looks like and also how to set up your torches to that right temperature to get them hot. Now, also, the other thing to remember here is thermal conductivity. Does anyone want to take a guess what that word means? Conductivity. Yes.
How easily heat goes through.
Yes. How easily heat passes through a metal, right? Gets transferred through that metal. So when we talk about copper, copper is high, which means that if I heat this center joint, you can almost guarantee it's going to be hot at these ends here because that thermal temperature, right? The temperature itself is going to transverse through that pipe to these further points on this pipe itself. You'll notice that aluminum thermal conductivity is low, which means that if I'm trying to heat a joint, I'm going to have to get all the way around it pretty quickly. Otherwise, it's going to that heat's not going to transfer well like it does with copper. That's why brazing copper is the easiest out of all of them. Brass is about moderate, and steel is low as well. So
that is something for the thermal continuity. You can see that super easy when you try to put together two sticks. I go show you later. Normally, we use that for safe material.
Yeah.
And you can put your torch really close here, really close, and you go brazing here, and you don't feel the heat. And you go say, how you doing that?
It's the thermal
It's exactly that.
Yeah.
It's that point. So you can be the flame, the torch really close to your fingers, and you don't feel nothing. You're not going to burn. More later, I can show you that. Okay?
Yeah, but if you're brazing a piece of copper, you'll find that it goes a good maybe a foot to foot and a half down the pipe, which is why, again, gloves and actual sleeves. So, and then alloys, flux usage. We won't get a whole lot into flux. I have a tube up there, I think, actually. You'll find that some things like this, right? This is 560, right? It's an orange stick. You'll notice there's also blue sticks. This on the outside coating is actually flux. So flux is basically like a material that's designed to clean surfaces in metal. Everybody knows here what PVC primer glue is, right? It's designed to clean the pipe before you apply primer, before you apply glue, right? For a clean joint. This flux is essentially the same thing. It helps actually allow the silver solder to bond to the metal on the surface by using a paste such as this.
We use that too in plumbing when we're doing drains and use it soft solder.
Yep.
We use something like that.
Comes in a paintbrush. So if you're in a spot where you can only get a certain amount of heat to it, and it's a dirty fitting, or you only get it so clean, but it's all messed up, and you have to get that connection made, you can always apply this, and then go to braze the actual joint and find that the metal adheres a lot easier, right? Flows a lot easier. It bonds a lot at a lower temperature. And that's just preparing the metal itself. It's not required on clean copper. It's only required in certain applications like we would talk about with, if you were trying to do copper to brass, or brass to brass, or brass to steel, or copper to steel, all the things, right? This stick is actually 56% silver with flux around the outside. And this is designed for brazing copper to steel, right? So a higher amount of silver allows the two metals to bond together. Silver is that bridge between metals, right? So if we take something like this, and this is probably, $200 a pack. It's very expensive. Yeah, these are like probably close to $30 a rod. But this is what we would use if we were trying to braze a piece of copper to a steel header on a compressor, or in larger pipe where I'm trying to build something custom that's going to then translate over to actual steel piping. So, but we're not going to get into that. And then last but not least, I also have some 82% silver here, which is designed for just aluminum repairs, right? So it's all about the base metals and the alloys that you're using to achieve the job. There is a base metal, and once you understand the difference between all the base metals, there is an alloy that is designed to bond those two metals together. And so there's just a couple things. Understanding your base metals and what goes together, what their temperatures of melting are, and their thermal conductivity, but also understanding what alloys are designed to bridge that gap between the two and at what temperatures, right? And they come in all different forms and sizes, right? This is 45% silver. This can also be used for brazing aluminum and making aluminum repairs. Obviously, the higher the silver content, the easier. Usually, it's the aluminum, steel, those areas. So, any questions so far?
Does this have any flux put into it?
Nope. It's not needed. Yeah, with copper.
So what's the other 85%?
There's phosphorus in it, so you can actually see here, right? It's 15% silver, 5% phosphorus, and the rest is actually copper. Some filler metals, yep.
But the important is for make a soft material for weld is the silver. If you want a cheap weld or a brace, use 10% or 5%. That package is around $200. The other, 100 or 85, something like that.
Yeah.
But the point is the brace, they can crack. So don't do it. Don't try save a little money, and time later you go have a problem with cracking bracings. So poor quality bracing, you know? That is why in the company normally.
We're almost to the hands-on, guys, so bear with me.
50%.
All right, so let's talk really quickly about just fittings in general. When we talk about copper fittings, you'll notice, okay, these are two different sizes, right? And you say, well, they're this big because, you know, this is a small pipe and this is a big pipe. But what we need to talk about is when we're bonding two metals together, right, we need to talk about that the actual depth of this fitting, if you look at the depth of it compared to the depth of this one, it is to match, the depth itself matches the diameter of the pipe. So if you look here, right, the depth of this connection is the same width as the actual diameter of the pipe. That is how we should be joining metals together, right? So you'll notice an 1 1/8" fitting is longer than your 3/4 fitting, just like this 3/4 fitting is longer than your 3/8 fitting, right? It's because the larger the diameter of the pipe, the more insertion that we need to ensure that this two metals are bonded together internally. Not only that, but also you'll notice here that thin line in between the fittings, this is your filler gap, right? If you take your pipe and you waller it all out, or the fitting's been beat to crap, and then you put your pipe in and it's extremely loose, there's a good chance that this gap on the side is way too large. And so what happens? We braze the pipe, we apply heat, we apply silver solder, and what happens is it gets sucked into the joint, but it doesn't stop there. It actually goes into the pipe itself because of the loose connection. What this is designed to do is this is designed to fit flush at the base of the fitting and then allow for a small gap to allow this filler metal to actually fill that gap between the two metals, right? Fill this entire gap. And so when you guys braze, you're going to find that the first time you go, and hopefully not, you're not able to actually fill this entire gap with filler metal, and that you'll find out why, and we'll get there. Nitrogen while brazing, we'll do that today. Today I'm not worried about nitrogen. Today we're here just to teach you the techniques on brazing. None of these copper pieces are going into an AC system. We're not going to take them out in the field and put them on someone's house. But I will show you, you'll see the difference between when we do nitrogen, when we don't do nitrogen, so we can just kind of hit that point home really quickly to you guys. And you'll see the difference between the two, right? Brazing with nitrogen, pipe is clean internal. It looks like the fitting did when it was manufactured. Brazing without nitrogen, you'll notice here, it builds up this, well, you can see it. Everybody's seen it, right? It's that black soot that you see on the outside that crumbles off in your hand, right? Always flow with nitrogen. All right, so let's get to the good stuff. All right, so everybody has your set of torches on the table. If you'll grab your tips, actually your torch tips, you're gonna notice on your tips, everybody has a torch tip, right? And most kits that you buy are gonna come with usually an extra tip. Maybe it comes with a rosebud, maybe, this is a rosebud here. Maybe it comes with an actual just standardized tip. This is also a rosebud. You can see there's multiple holes at the tip, right? This is also what we call a cutting head torch, which we're not gonna get into today. But at the edge of that tip, right, there is a small little hole. That hole, right, is to be protected. You'll see it right there. Yes, if you drop your tip on the ground and your tip hits the concrete and it actually messes up that small perfect circle at the end, you need a new tip, right? You can't put can't put that back together again, right? But at the base of that tip, you're going to find that there's actually a number. What number do you guys have? You have 2. So tips, everybody knows what tip number they have. They either have a 2 or they have a 0. Does anybody want to take a guess as to what that is?
Is that the size, the diameter of the hole?
Yes. Yes. This is the size of the diameter of the hole at the end of your tip. This is going to determine how much fuel, right, comes out the end of your torches, which is going to determine what? How hot the torches actually get. What if I told you there was actually a chart for this? Every manufacturer has a different chart for the fittings that you have. They are rated for different sizes. You'll notice that there is a 00, a 0, 2, 4. Then you'll notice to get into the rosebuds. We have a number 6. We have a number 8. You know what size your rosebud is? This is a 17. 17, 15? Yeah, mine's the same. Okay. So why does it matter that we know what size our tips are? every tip is designed for a different size pipe. So if you just grab a set of torches and you start brazing something and you have a 00, and let's say you're brazing 1.1 inch, you're going to have a really hard time getting enough heat on that joint to actually braze. It's not that you don't know how to braze, it's that you have the wrong tip, which isn't allowing enough fuel to leave the end of your torch tip to actually braze that pipe. You'll notice here we have a sizing range at the bottom. So we made this chart actually internal to Caleb's. I went through a bunch of different manufacturer websites, took all their information, and we put it in this nice little beautiful chart. These are your average torch tips you're gonna find for HVAC. When you go out and buy a Uniweld kit, or if you go and buy a Victor kit, or whoever you buy your kit from, they're gonna come with one of the two things. It's gonna be a 00 or a 0, and then usually a 2, right? And this just covers your wide range. So if I take a number 2 tip, right, which is designed for 1/2 inch to 1.5 inch, and I try to braze 1/4 inch, I'm gonna find that I have too much heat with my torch tip. I can't turn those torches down low enough. Now there's guys with experience who can braze with a number 2 at that low temperature, just because they keep the flame far enough away. However, when we talk about selecting tip sizes, you have to understand what their limitations are. So if I really was brazing 1/4 inch, I should use a 0 or a 00. This is also important when we go out in the field and we start servicing actual pipe. You know, you got one guy who's just blowing through 1.1 inch, and you're over here just sitting on it because you can't get it hot enough to actually get the solder to melt around the entire joint. And it's probably because you have a 00. You can't get enough fuel. It's not that your skill is low, it's just that you don't understand tip selection, right? Every tip has a number. If your number is a weird letters and something, you can go to that manufacturer's website and actually look up what the ratings of them are for. It's also important to understand what tips you have, because every tip, because right, we just talked about it, they're designed to basically expel more fuel the larger they get. So what else matters when we're trying to expel more fuel, right, on a number 2 tip? This number 2 tip takes more fuel, right? So I should have to adjust my torches and my regulators for that tip as well. So you'll notice here we have a chart, acetylene pressure and oxygen pressure. You'll notice that a 00 is 5 and 5, a 0 is 5 and 5, a 2 is 5 and 5. But you'll notice as we get bigger, you have to increase that pressure at your regulators to actually allow enough fuel through. You're gonna find that these regulators are designed to connect directly to your tank. Your tanks are under a very, very high pressure. This is designed to step and reduce that pressure down to allow just the right amount to get to the end of your tip, right? Now we have adjustment knobs on our torches to also give us a little bit more control as well, but if you don't have enough back pressure getting to the end of your tip, then you're not going to be able to create the flame that you need anyways. You're going to struggle trying to light it. You're going to struggle trying to get to the temperature that you need to make it happen. So when we build our torches, what we're going to do is we're going to take our actual gauges, right, connect them to our tanks, and as we work our way back to the hoses, when we go to turn them on, we're going to make sure that we know what tip size we have. We ensure that our pressure gauge is set to the right pressure, right? And then we're going to work our way to the end where we can actually light our torches. This is all information that you should understand and know in regards to your torches. If you have the wrong size tip, if you have the wrong size settings set up, you may find that you set your tank pressures to 15 and 15, and you've got a 00, and every time you go to turn that thing on, it just goes psh, and you can't get the pressure low enough to light the flame. And that's because you don't understand the type of tip that you have and what fuel pressure it needs to actually operate correctly. All of these things have to be tweaked and modified. You should always check your actual settings on your tank anytime you go to store it and bring it back out to make sure it hasn't moved. I mean, I could do this with one finger, right? So you set it in your truck, you move it, you carry it upstairs, you carry it on your back, you toss it through an attic. It's going to change. So you should always verify that it's at the right pressure when you're troubleshooting, starting your torches and getting them going. And then last but not least, before we get into the good stuff here, is when we talk about larger tips, we talk about higher pressures, we also need to talk about fuel consumption, right? Because this is a thing. This is a commodity. Your tanks only hold so much fuel before they're completely empty. So if I'm there brazing a 1/2 inch pipe and I have the choice between a rosebud tip and a 0, right? Which one should I use? Well, we know that this applies the right amount of heat. This is too much heat. But let's say this is all I have. Well, now here's the problem. as I work through this job and I start brazing this pipe, you'll notice that this tip probably consumes 3 times as much fuel as this one. And so I am going to run out in an hour, where as opposed to if I use the right tip with the right pressures, it could have lasted all day, right? So this is the other side of selecting the right tip and why the right tip matters. Because the right tip for the right type of pipe, the right size of pipe, the right amount of heat also allows you to conserve the fuel in your tanks as long as possible. Nobody wants to have to walk down 7 flights of stairs back to the Connex to get a tank because they don't know how to set their torches up, right? Center point. It's just one of those things, guys. So this is stuff that we teach now that usually is taught in trade school so that you understand how each single piece affects the other. Maybe you didn't know that there's this many layers to just setting up torches, but there is, right? This is important stuff. So, okay, so let's start putting our torches together. So you'll notice here you got 2 different regulators. You have oxygen and you have acetylene. Usually they'll have a tag on them that says oxygen and the other one says acetylene. You'll also notice the difference is your oxygen regulator might have a green knob and your acetylene might have a red knob. So an important thing about this, guys, you'll notice that also the tanks are different sizes. You'll notice that your oxygen tank opening is bigger than your acetylene tank. There's a reason for that, so you don't mix them up. So as we put these on our tanks, you're going to notice that there are no rubber gaskets on the back side of these actual connectors, right? And the reason that is because they're supposed to be installed with a crescent wrench. That crescent wrench is designed to torque down 2 brass connections together to make a tight seal. All right, so if you got your oxygen and your acetylene regulators on your tanks, go ahead and torque them down with a crescent wrench. We don't use a pair of channel locks. Why don't we use a pair of channel locks on our torches? Anybody? These are brass connections, and so like a nitrogen regulator or torch regulator, when you take a set of teeth-marked pliers to them, it will actually indent on the actual brass connection and you will round off your connection to your gauges. I don't know about you, but I don't want to have to buy a new torch set just because I don't know how to use a wrench. Always when it's flat like this, you're going to use a crescent wrench or a flat wrench, nothing with teeth. And again, you'll see the guys' torches where it's all eaten up. Over time, it will round those corners to the point where you can't get it off anymore. And there's nothing worse than having to explain to your boss why you can't get a job done because you can't change your tanks because they're empty. So it says 555, right? I like to still do somewhere close to like 8 and 8. I like to go a little bit over because what you'll find is when you set it to 5.5, right, and you go to turn on the torches and the fuel starts flowing, the pressure drops. And so you almost have to set the 5.5 while it's running, otherwise it's a 3.3, and then it's not enough. And so I always go to 8.8 to account for that loss when I go to open it up, because it needs to be a constant 5.5 flowing, not a 5.5 sitting on the tank. So if you've got your torches and they're all set up and all your connections are nice and tight, we're going to walk through the next step, and that's where we basically take our torches and we turn our knobs all the way out. Now, not all the way out to where they fall out of the actual torches themselves, but to the point where we actually turn them to where they're free spinning. You'll notice that when I go to turn it in, I find a little bit of resistance. That's where I want to stop, right? You want it all the way out because, again, we're setting these torches up for the very first time, which means that we want to make sure, and as you can see, you can go too far. They will just fall out. The other thing to remember, too, is if you tighten these all the way in, which you should never do, you'll find when you go to pull it back out that you might actually unscrew the brass connection behind it, and the entire orifice and spring and diaphragm will come flying out, and it is a lot of fun to put it back together. So again, you just want to spin that all the way out to where it's loose and you don't have any resistance, because we're trying to set up these torches brand new, right, to these regulators. Okay. Now let's go over the actual torches and the knobs and what they look like. So you'll notice on every tank you have 2 actual, let's say displays, right? Those are actual readouts on the tanks. There's one on the left, there's one on the right. Does anybody want to take a guess as to what is what?
One of them shows how much fuel you got in the tank, and then the other one is to regulate how much comes out of the tank.
Correct. So you'll notice that one gauge is designed to tell you how much fuel is in the tank, and the other is to tell you the pressure on the hose. So this is important because you don't want to mix the two up. One is going to tell you how much is in your tank. it's important to understand how much fuel is left in that tank. So if I'm taking my torches out of the truck for the first time and I have to go into a building or walk across the roof, I want to make sure that my tanks aren't empty already before I go up there to make a repair and have to go back and get another set of tanks. So one is for the actual pressures in the tank. You'll notice that some say, like your acetylene is going to say 100% full, or it'll have a pressure reading. So I think yours, one of these says, not yours, okay, yours is Victor. Yours, okay. This one is easy to read. It actually shows you, you'll notice on this one here is different than the Victor setup, right? See the acetylene?
Yeah.
See how it says quarter, half, full? That's easy to understand, right? Now that we understand the difference between both of the regulators and what's open and what's closed, as well as how much is in the tank, and you're confident that your connections are solid, go ahead and open the pressure on your tank, but do not turn the knobs at the edge of your tank.
Okay.
Yeah,
something,
not these.
guys.
Yep.
Parcero, something that I want agree.
Yep.
Service range. Okay. Some fuel tanks in the past, they don't have that handle. The handle that you have there, that one. But we have the case here that we have two tanks, that one and that one here, they don't have the handle.
Yep.
That was before for safety things, no?
No, it's all
I don't
over
know,
the
that
place.
is old school. I don't remember why. But when I started in the HVAC area, we need all the tanks coming without the handle in the fuel tank. So mandatory we need to use the range, the service range. It's super easy. Just put there, open quarter. That is something important in the fuel tanks. Open, and we need leave the range all the time connecting in something case that we have emergency, and we need close so quickly the fuel tank, okay?
Yep. So the important thing that Ricardo's talking about here is that we never want to open our tanks 100% open. There is no benefit to opening your fuel tank 100% open or your oxygen tank 100% open. You are never going to need the entirety of that tank and its full flow volume through the actual opening that it has. So again, you can just turn it a quarter turn. That allows you that if you have an emergency, if someone cuts your hose, if you have an issue with your torch or something, Lord forbid, catches on fire where you're working, you can turn off the fuel to your tank quickly instead of having a service wrench like he's talking about and sitting there and trying to ratchet it closed a million turns, right? You don't have to open your tanks 100% to use them. Again, we're using a step-down pressure, which means you just need to be able to get enough pressure through your tank, through your regulator, to the end of your hose for what we're doing. And for HVAC, it's actually not a lot of fuel at all. So don't crank those knobs open, crack them open a quarter turn, maybe a half a turn until you see that your tank's actually open and that you see the volume show up on there. And you don't, again, with the service wrench, it's a square knob. So you don't want to take a set of channel locks. You don't want to take a set of pliers to it. You can use a crescent wrench, but every set of torches that you buy is going to come with a little tiny metal wrench. You can also get a service wrench like Ricardo has, which I think he just had. Where's your service wrench at, Ricardo? It's the same wrench that you use that has that extension piece to open up the service valve on your 3/8 line and also on your suction line. Right? This is the same wrench that you guys use to open the service valves on systems to let the gas go. Right? You just pull off the tip, and it's actually that back piece here is designed to go on top of your acetylene tank. So you already have one of these. That's what it's also used for. Okay, so if you've opened up your tanks, but not your regulators, right? Regulators, we still want these turned out. We want everything off except for at your tanks. We're going to now leak check your tanks. This is an important safety step that you should always do, no matter how long they've been stored. Doesn't matter if you used them the day before. Things change when you put them in your service truck. When they fall down, they get jostled, they get hit. Someone might have knocked them over running into them with their car and then stood it back up and you didn't know about it. It's always an important safety factor to ensure that nothing has happened to your tanks and you are not leaking fuel at your connection. I don't care how strong you think you are. You could torque it down as hard as you want to. If the tank you got is damaged at the opening, because we don't make these tanks ourselves, we get them from a warehouse, we get them from a local supply house. If the actual round connection where your brass fitting sits is nicked, cut, damaged, or is dirty, and you make that connection and you crank it down, it will still leak fuel. And the last thing you want to do is turn on an open flame while your tank is leaking fuel in an enclosed space. You will cause an explosion. So this is a safety factor that we do not skip. So we have soap bubbles here. We're going to go through and we're going to soap bubble every connection at your tank, and then we're going to apply pressure to the hose and then leak test it from there. So, all right, pull your tanks.
You want us to take it out?
Yep, pull the tank out. So now we're going to leak test. We got a rag for you. We're going to leak test the connections. So these are open.
Yeah, we have them set up.
Okay. So I'm just going to. See, look at that. All right, so guys, if you come over here really quickly, so you'll notice here how they tightened it and they thought they were good, but you can see here now that I've soap bubbled it, we could have easily skipped this step. And you can smell it. Acetylene has a certain smell to it, right? And the reason we leak test is because this can easily happen to any one of us, right? And again, they could have tightened it perfectly. However, you never skip this step because this happens almost 9 times out of 10 when you least expect it. So, okay. Go ahead and tighten it. And you wouldn't know. He would set it down, he would start brazing, and then the next thing you know, flame goes in the right place, and then it lights. So. You can pull the tanks out if it's easier. No. So we only have pressure from here to here, not on the hose yet, because this is turned out. So now you can pull the tank out because it's easier. Good. I say it's easier. It's a great answer. And then you can leak check it outside of that, because then you can turn the bottle upside down, turn it sideways. You want to get to the top, the back, and then the connection here, because you never want to assume that the connection from the factory is good when it opens. Because I've had them where this nut here is loose, and it leaks actually after you start to open it. And they wouldn't see it at the factory because it's closed.
Check bubble subs here, bubble subs in the tank, bubble subs, and any connection. So here. Here? No, there you don't care, but you have a seal. You have a ring. That one really small here, and that one here in the top is your seals. And normally we use that with the hands for move a little bit the direction in the tip, depending the position where you are working, okay? So that one is with the hands, the other is with the wrench, okay? Okay, do it.
Right there in the palm.
Here. Okay, so you can see something? Nothing, everything is good.
Nicely done.
Everything is good.
Something important to remember, we aren't setting pressure at the knobs on top of the tanks. These are for open close. We're setting at the ends, which we haven't done yet. So you don't want to do setting at the top, you set them at the ends, right? There's a big difference there. One is just to open and close the tank. The other is to actually do it. So go ahead and set the pressures on your hoses. Make sure that everything is turned off. All your knobs are closed. Your torch tip is on. All your hoses are tight. Go ahead and set your pressures to the tip that you have. When we talk about setting our tip pressure to 5 and 5, you have to remember that when I set my pressure and then I open my hoses to light my flame, that actually my pressures are going to fall. So although it may say 5 and 5, I would probably set it closer to 8 and 8 or 10 and 10, because when I go to open up my actual manifold to light my flame, you're going to find that the pressure actually drops down. And so when it drops down, if I set it to 5 and 5, it might be 3 and 3 when I'm trying to light my torch. And I'm not going to be able to create enough heat. I'll be able to light my torches, but I won't be able to get the right amount of heat out of it the way it's designed. And so we set it a little bit higher than what it says on here, just so that we can maintain an even steady flow of 5 psi and 5 psi. If you've actually put pressure on your hoses, you need to go back and now leak check your connections at your actual manifolds for your hoses and your connections at your actual torch tip to make sure that you are not leaking acetylene or oxygen. This is the second step of fuel checks that we do for safety reasons. We work our way from our tank to our hoses. When you guys get good at this, you can do all this check at one time. However, because we're doing this in a large class setting, we're going to do this one step at a time. So if you've already set your pressure on your tanks, you need to leak check your connections. You guys already leak check them?
Yeah.
Good. Okay. For the guys who are lighting the torches, so we're gonna just practice and go through the safety precautions of lighting torches, the difference between doing it right and doing it wrong. I'm going to do it wrong a few times so you can see the problems that I'm going to create. So striker, what is a striker? It's not just a cool nickname for a biker gang. It's a device here that's designed to rub flint against a wheel, right, to create a spark. This is designed so that you don't have to keep your hand close to where the torch light's at, because again, we are hot enough to melt copper, so above 2,000 degrees at the end of our torches, so we want to make sure that our fingers stay away from that. You'll notice here at the end of your striker, there is a piece of flint. This is an expendable piece. You'll notice that it actually, no one ever knows this because they use it to the point where it just gets down to steel, it's changeable. So when you buy a striker, it comes with actual flint pieces that allow you to unscrew it and get a new piece and screw it back on. So when this flint gets depleted out of my striker, I go and I buy a replacement pack, which almost every distributor has, and then I replace the tip and put it back. If you go too far, you'll notice that you actually will etch away at this and your striker won't light. You see those guys out in the field where they're like, oh, it just won't light. And it's like, well, you know, they've never changed the actual tip since they bought it. These aren't expendable. This is. So the more you use your torches, the more you're going to use this up, and then you have to replace it. Right? So if it's not actually sparking, there's a good chance it's either wet or it's used up. Okay, so that's your striker. With my torches, this is an important part of it too, right? So we have two different things on here. You'll notice, I know it still lights, yeah. That's why I use it.
Tight it.
Okay. You'll notice here that it'll either say oxygen and gas, or it'll say O and F, oxygen and fuel. You'll notice that the hoses are also colored. Mine are so worn and old that you can't even tell the colors really much anymore. This is what it looks like when you're colorblind. You can't tell the difference between the two, but remember, green is oxygen, red is your acetylene. You'll notice here that we also have our tips. At the base of the tip, there's a lot of different safety devices in this torch rig that if for some reason, if I don't set the pressures right and the fuel starts to ignite within my torch down into my handle, it has a device that's designed to cut that fuel off and actually put that flame out. So if you find that it's lighting up and it's making a really screaming, squealing noise at the tip, it's usually because it's combusting inside the actual manifold and it's turning itself off or limiting the fuel to not light your entire rig on fire and explode, right? And so that also, another sign of improper combustion with your tip, whether it's dirty or the seals are bad, is you'll find that the tip itself gets extremely hot and your actual handle gets extremely hot because, again, some of that fuel might be combusting inside the tip itself, which is creating that heat, which is going to make it too hot to hold, which means you need to take your rig apart and actually inspect it. This isn't a brass-to-brass connection. There's actually, if you look and you take your tips off, you'll find there's little black O-rings in the end. These O-rings are to make a seal between the different fuel sources and the connection at the top. Taking these tips off over and over again, or improperly burning or burning a lot. I mean, and this one looks like it, I think, the most. We take your tip up, I think yours was that way. Oh, you put it on with a crescent wrench, didn't you? Look at you. Now, here's the thing about putting your tips on with a crescent wrench. You can do it. However, it's one of those things that if you over tighten it, there's also a good chance that you're going to squish your O-ring. And so if you look here, this one actually is somewhat squished. So if you see, I'm just going to get a flashlight real quick. Show you the difference. See how that O-ring's somewhat intact, and then see how this one's all chopped up and see it's missing chunks. See how this one's missing some small pieces? This one was just tightened with a crescent wrench. So it's easy to assume that this has to be tightened with a crescent wrench because you see it. But you have to remember your tips are designed to come off with fingertips. You'll notice that this one right here, see how it got squished with a crescent wrench?
Okay.
It's important to inspect your rigs and make sure that your O-rings are good. Notice how this one is squished right there? See the pieces missing? This one's intact. These are designed to be hand tightened on your torches. Hand tight. The O-rings make the seal for you. You take a pair of crescent wrenches to it, you're going to squish your O-rings to the point where they no longer seal. See the chunks missing out of that one? Mm-hmm. That one's still intact. Mm-hmm. Right there, see the end? See it's got pieces missing? Mm-hmm. This one's intact. What happens when you squish with a crescent wrench? Hand tight. And that, again, these are designed to come off with the fingers, right? To take them off without having to put a wrench on them. Now you can leak check these as well, which, you know, it's kind of hard to do because you have to have fuel coming out the end to do it. But again, if you inspect your O-rings, you don't need to leak check it, right? Also, the other thing to remember is that if you take a set of wrenches to the end of this copper connection here that you see here that has the tip on it, I say copper, I'm not even sure what the metal is here, but it's actually threaded into the bottom of this. And so if I actually pull it, I can actually pull this tip out of the connection or it becomes loose. And so it's just, again, ensuring that your tips, they're taken care of, right? When you finish your torches, you should not take your torches and then just toss them in your rig, right? And go down the road. What I like to do, especially if it's a tip that I like, I take my tips off and I put them in a bag and then I put my torches in my rig, right? And that's because these can easily get damaged at the tip. And then when you go to braze, you can realize you can't braze. And there isn't a whole lot of fixing this. There is a kit for cleaning them. However, we're not going to get into that on this class, but it basically just looks like a bunch of different sized, threads to actually clean up the points on the tips.
You can see that depending what number, we choose the number and we have a, what is the name?
Gauge size, yep.
No, the
File?
file.
Yes.
That is the name for that one, for clean for outside, and depending which one, you can see that is a specialty. They have a thread here in the
it's like
in the begin.
Yeah, it's like a file, a circular file that's designed to clean the tips off themselves.
Look at that. You see that small.
That does not come with every set of torches. You have to buy that.
Okay.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.